Okay, so let's see today's question. Administration cost and marketing spend of 50 companies are given along with profit earned. The target is to prepare the machine learning model which can predict the profit value of company if the value of its R&D spend, administration cost and marketing spend are given. So it's given that construct different regression algorithm, divide the data into train set and test, then calculate different regression metrics, choose the best model. Okay, so let's go through the program. First we have to import pandas, which is the library which is essential for data manipulation and analysis. Then read CSV file from the data set given into the pandas data frame. It looks like the file located in the user's download directory. Next is print head, describe and info. So the head is displays the first rows of the data frame, allowing for the quick inspection of the data, and the descriptive calculates the print summary statistics like mean, standard deviation, mean, max, quantiles of each numerical column in the data frame. Then the data info provides the concise summary of the data frame, including the data types of each column, the number of non-values and memory usage. So this is the output which comes for the particular, all the mean, max, all the R&D spend and all those quick inspection for the data which will be provided. Next is missing values. So nothing but data cleaning. It checks the missing values using data.isnull.sum, which calculates the number of missing values in each column of the data frame. The output shows there are no missing values of the column. In R&D spend 0, administration 0, marketing spend 0, profit 0. So this is what it shows. Next is feature selection and data splitting. So X and Y, nothing but features, as well as Y defines targets. So the first line, X data, R&D spend, administration and market spend, it represents that columns as the feature like independent variables and assign them to variable X. Next is Y, that is data profit, selects the profit column as the target variable and assigns it to the variable Y, which we have defined as target. Next we have to train and test. So splits the data into training and testing. So first is import train test split function from scikit-learn, which is used to split the data into training and testing sets. Next is splits the data into training and testing sets. In that, test size 0.2 means that 20% of data will be used for testing, and random state 42 ensures that the split is reproducible. So next here there is some missing. Let me check. Okay, so there was a little glitch in that. So next comes the model training. So we have chosen linear regression, decision tree, random forest and SVR. This model is trained that nothing but like from the class linear regression is imported from a scikit-learn. Later linear regression LR model, which creates the instance of linear regression model, and this linear.model.fit that trains the linear regression model using training data. So the same thing is done for different models like decision tree, random forest and SVR. So next we come to the other part of the code, which is nothing but predictions. So first is predicts targets values like profit using the trained linear regression LR model and decision T and X test, all these stuffs. And then random forest regression imports random forest regressor class which is used for. Okay, so now from sklearn.matrix import mean square absolute error, mean square error, as well as R2 score. So this line imports three commonly used metrics for evaluating regression models from the sklearn matrix model. So I'll say the importance of these three. Mean absolute error, that is calculates the average square difference between the predicted and actual value. Then R2 score, which calculates the coefficient of determination. And then mean squared error calculates the average square distance between the predicted and actual. So this is small change that mean absolute error is the average absolute difference between the predicted and actual value. Later, diff evaluate model y true y pred. This line defines a function called evaluate model that takes two arguments, y true, that is actual value of the target variable, y pred is the predicted value of the target variable. So the importance of these two. Next is MSE, that is nothing but mean square error between the true values y true and y pred for the predicted values using the mean squared error function. Then R2, that is R2 square, calculates the R2 squared scored between true values and predicted values. Then return this, like this function returns the calculated MAE, MSE and R2 square as a tuple. So next is this, which is evaluate each model and print matrix. I have written it in a command so that you can be more clear about it. So this line calls the evaluate model function with the true test values and the predictions from the linear regression model. The return MA, MSC and R2 square are stored in a LR matrix variable. So the same thing is done for DT matrix, RF matrix, FER matrix, and the same thing is printed so that all the squares over here, like it prints the evaluation matrix MA, MSC and R2 for each of the four models. The output shows the performance of each model on the test data. Next is model matrix, that is linear regression, decision tree, random forest and SVR. Like it creates a dictionary called models.matrix to store the matrix for each model. The key of the dictionary are the names of models and the values are the corresponding metric tuple. So now the best model name, that is like this line determines the best performing model based on mean squared error. So this model matrix key equal to lambda, X model matrix and all, that is finds the key in the model matrix dictionary that has the minimum value according to the key function. And lambda, that is a function that takes the model name X as an input and returns the MSC value for the model. Then we have to print the name of the best model and its corresponding matrix. So in summary, this code trains and evaluates four different regression models like linear regression, decision tree, random forest and SVR on the given data. This calculates common regression metrics for each model and identifies the best performing model based on the lowest MSE. Thank you.